Imagine you are walking home on a quiet, dimly lit street. The air is still, and the only sound is the echo of your own footsteps against the pavement. Suddenly, a shadow shifts in the corner of your eye. Your heart instantly begins to pound against your ribs like a drum. Your palms become clammy, and a cold shiver traces a path down your spine, despite the warm night air. In a fraction of a second, before you even consciously understand what you are looking at, your entire body has been hijacked. This intense, overwhelming experience is fear, and it is one of the most primal and powerful emotions in the human catalog. We often think of fear as a weakness, a negative sensation that we must conquer or hide from. We associate it with cowardice or anxiety, a glitch in our mental programming that holds us back from truly living. But this perspective is a profound misunderstanding of a biological masterpiece. Fear is not a design flaw. It is, in fact, the most sophisticated and oldest survival tool we possess, a legacy inherited from ancestors who huddled in the dark, stalked by predators with sharp teeth and empty stomachs. The feeling of fear is a universal human language that does not need translation. It fires in the brain of a child scared of a monster under the bed, just as it did in the brain of an early hominid facing a saber-toothed tiger. The context has changed, but the intricate machinery remains the same. Today, we are going on a journey deep inside your own head to deconstruct this feeling. We will pull back the curtain on the silent, lightning-fast orchestra that plays within your nervous system, turning a simple sound or shadow into a full-body emergency. Forget everything you think you know about being scared. We are about to explore the science of fear. To understand why your body reacts so violently to a shadow, we must travel to the very center of your brain, where a tiny, almond-shaped structure sits in each hemisphere. This is the amygdala, and it is the undisputed sentinel of your emotional world. Think of the amygdala as the most vigilant security guard imaginable, a guard who never sleeps, never blinks, and is constantly scanning the security cameras of your senses. Its one and only mission is to detect danger, and it is not picky about how it gets the job done. The moment your eyes catch that shifting shadow, the visual information splits into two distinct pathways. The first is the high road, a slow, methodical route that travels to the visual cortex, the part of the brain that carefully analyzes shapes, colors, and details to give you a high-definition picture of reality. This road, however, is a bureaucrat. It is too slow for life or death situations. The second is the low road, a neural shortcut directly to the amygdala. This road is a crackling, high-speed emergency line that prioritizes speed over accuracy. The image sent along this path is grainy, blurry, and incomplete, just a crude sketch. But the amygdala does not care about details. It reacts to this rough sketch with the full force of a biological army. Long before your conscious brain can shout, it is just a tree branch. Your amygdala has already initiated the alarm. It has done its job, and it has done it in milliseconds. This tiny cluster of neurons is not a philosopher. It is a trigger-happy guard with a simple philosophy. It is far better to launch the alarm 10,000 times for a false shadow than to miss one genuine predator. In the brutal accounting of evolution, the cost of a false positive is a little stress, but the cost of a single false negative is extinction. Once the amygdala has hit the panic button, it does not send a polite request to the rest of the body. It sends a command that is absolute and non-negotiable, immediately seizing control of a network known as the autonomic nervous system. This is the part of your nervous system that runs on autopilot, controlling digestion, heartbeat, and breathing, and it has two opposing sides. The first is the parasympathetic system, the rest and digest mode, responsible for calm, relaxation, and storing energy. In a crisis, this system is instantly shut down. You cannot peacefully digest your lunch while fighting for your life. The second is the sympathetic nervous system, the fight or flight switch, which is now flipped on with violent force. The amygdala, through the hypothalamus, sends a distress signal directly down to your adrenal glands, two small organs sitting atop your kidneys. These glands respond by flooding your bloodstream with a potent chemical cocktail of adrenaline and cortisol. Adrenaline is the immediate action hero. It latches onto receptors in your heart, forcing it to beat faster and harder, pumping oxygen-rich blood to your large muscles in your thighs and biceps so you can run or fight with superhuman strength. At the same time, it constricts blood vessels in your skin and non-essential areas to prevent fatal blood loss from a potential injury, which is why you suddenly turn pale. Cortisol, the slower-burning stress hormone, follows to ensure your body maintains this high alert status by dumping glucose into your blood for an immediate energy surge. Your breathing becomes rapid and shallow to take in more oxygen, and your pupils dilate wide to let in every available particle of light, sharpening your vision to spot the threat. You are no longer a calm, thinking human. You are a vessel of biological combustion. Among the well-known responses of fight and flight, there is a third, more mysterious reaction that often comes first: the freeze. This is a state of profound physical paralysis, a suspension of all movement that feels like being turned into a statue. To a casual observer, freezing might look like cowardice or inaction, but it is actually a highly adaptive survival tactic with a deep evolutionary history. For many predators in the wild, movement is the primary trigger for an attack. A hawk's visual system is wired to lock onto the erratic twitching of a rodent. A large cat's predatory drive is unleashed by the sudden scuttle of fleeing prey. By freezing completely, you are effectively becoming invisible, dropping off the predator's neural radar. This is not a conscious decision. It is a reflexive neurobiological maneuver. Scientists have observed this in the lab using rats exposed to the scent of a cat. Even a predator's scent alone induces an immediate, rigid immobility. In the human experience, this freezing response is often what we mean when we say we were paralyzed with fear. It is the moment your body hits the pause button, a last-ditch effort to assess the situation in complete silence before committing to a metabolically expensive sprint or a dangerous physical confrontation. This entire process is governed by a delicate dance of brain chemicals. While adrenaline primes the engine for explosive action, the freeze relies on a braking mechanism. It involves the activation of the periaqueductal gray, a region of the brainstem, which locks down the motor system. It is as if your brain floors the accelerator and the brake pedal at the same time, creating a state of electric, coiled tension. This moment of stillness is not a passive submission. It is an active, terrifying gathering of data and energy, a breath held before the storm breaks. As the immediate wave of adrenaline begins to recede, the long game of survival commences, orchestrated by cortisol, the steroid hormone that acts as the body's built-in chemical fire extinguisher, yet paradoxically stokes the flames. If adrenaline is the fire alarm blaring in your ears, cortisol is the slow, silent burn that follows. Its job is to sustain the state of high alert, ensuring you do not drop your guard after the initial threat passes. To do this, it fundamentally changes your body's fuel economy. Cortisol rushes into your cells and forces them to turn off the doorways that normally receive stored energy. Instead, it signals the liver to dump a massive reserve of glucose directly into your bloodstream. This guarantees your brain and muscles have an uninterrupted supply of rocket fuel to make quick decisions and sustained movements. However, to do this, it must shut down functions that are not critical to immediate survival. This is why, during intense fear, your mouth goes dry. The salivary glands are not needed for fighting a bear, so fluid is diverted elsewhere. Your stomach stops churning and digestion grinds to a halt, creating that hollow, empty feeling known as butterflies. Even the prefrontal cortex, the logical, rational part of your brain behind your forehead, is chemically dimmed. When you are fighting for your life, deep philosophical thought or complex moral calculus is a deadly distraction. The brain sacrifices cognitive nuance for raw instinct. This explains why, in a moment of terror, your thinking can become fuzzy, and you might struggle to recall your own phone number. The body is a calculating accountant, and it has decided that a few lost brain cells are a small price to pay for staying alive for the next 60 seconds. Fear is not just a feeling. It is a massive, systemic reallocation of resources from the future to the terrifying present. The mechanism of fear is not only concerned with the present danger. It is a time traveler, an architect of the future, with one of its most crucial functions being the forging of vivid, seemingly unerasable memories. Imagine a world where you could not remember what was dangerous. You would touch a hot stove, recoil in pain, and 10 minutes later, do it again. You would be a biological failure, doomed to repeat fatal errors. Evolution solved this problem by hardwiring the amygdala directly into the memory-making machinery of the hippocampus. When cortisol and adrenaline saturate your brain during a fearful event, they don't just flood the body. They stamp the details of the moment into your memory with a branding iron. This is the neurological basis of flashbulb memories. Those moments so intense that almost everyone remembers exactly where they were and what they were doing when they occurred, such as during a global tragedy or a personal trauma. The system is designed to ensure that the sensory information of the threat, the specific smell of a predator, the sound of a rattlesnake, the layout of a dark alley, is seared into your brain with high-definition clarity. The amygdala instructs the hippocampus to record not just facts, but the raw, visceral texture of the moment. However, this system has a dark and painful flaw. Because it is optimized for survival and not for objective journalism, the memories it creates are often fragmented and chaotic. You might vividly remember the color of a car's headlights, but have no memory of the sound that followed. More tragically, in conditions like post-traumatic stress disorder, this survival mechanism shatters. The memory is so potent, so perfectly preserved, that it refuses to be filed away in the past. The amygdala keeps rereading it as a current, present threat, causing a person to relive the full chemical terror of the original event, not as a memory, but as a horrifying present reality. We often assume our fears are our own, crafted purely from our own life's scrapes and traumas. The science, however, tells a more haunting story, suggesting that the shadow of a past we never lived can reach into our present. This is the science of epigenetics. It posits that while your DNA sequence, the genetic book itself, is fixed, the way that book is read can be modified by the environment, and these sticky note modifications can be passed down. A landmark study took a group of mice and conditioned them to fear the smell of cherry blossoms by pairing the scent with a mild electric shock. Predictably, these mice had pups that were also terrified of the cherry blossom smell, even though they had never experienced the electric shock. This was shocking but still could be explained by observing the behavior of their anxious parents. The true breakthrough came when they took the sperm of these conditioned male mice, performed in vitro fertilization with females who had never smelled the scent, and raised the pups with surrogate mothers who had no fear. The next generation was still born with a heightened sensitivity and a structural change in their brains specifically dedicated to processing the cherry blossom odor. The traumatic memory of their grandfather had been chemically coded into their genetic lineage. In humans, this offers a biological window into why anxiety disorders can run in families. It is not just learned behavior, it is a biological inheritance. The intense stress experienced by a grandmother during a famine, a war, or a violent conflict may leave a chemical mark on her genes that tunes the nervous systems of her grandchildren to be more reactive and hypervigilant. Their amygdalas are primed to fire louder and faster, even in the absence of a rational threat. We carry within us a chemical echo of a past that is not our own, a ghostly inheritance of survival strategies hard-won by our ancestors. After this deep dive into the dark waters of our neural machinery, the question remains, are we just slaves to our amygdala? The final, most crucial part of the science of fear is not about how the fear response is triggered, but how it is silenced. The hero of this story is the prefrontal cortex. Earlier, we learned that it is dimmed during the peak of terror, but once the initial shock subsides, it comes back online as the voice of reason. The amygdala screams "snake" and sends you leaping into the air, but the visual cortex, having taken the slow, high road, finally delivers its detailed report to the prefrontal cortex. The executive center analyzes the data, sees it as just a coiled garden hose, and sends a powerful, calming signal directly down to the amygdala, telling it to shut off the alarm. This neural braking system is the biological basis of courage and emotional intelligence. Courage is not the absence of fear. It is the triumph of the prefrontal cortex over the amygdala. The incredible, hopeful truth of neuroplasticity is that you can strengthen this connection through practice. Every time you choose to stay on a stage despite a racing heart, or strike up a conversation despite social anxiety, or ride a roller coaster through the first drop, you are physically rewiring your brain. You are laying down thicker, faster, more efficient wiring from your rational brain to your emotional sentinel. You are not removing the fear. You are learning to simply let it be background noise. The amygdala will always do its job, firing its warning shot, but a strengthened prefrontal cortex can lean over and say, "I see that, I hear you, but I have got this." The science of fear is ultimately a story of a beautiful, ancient partnership between a vigilant bodyguard and the rational master who learns to take back the reins.